So first we're going to look at when sine, cosine, and tangent are positive and when they're negative, because if you know the answers to these questions, you'll be able to better see what quadrant your triangle's in. And if you don't happen to know quadrants, quadrants go 1, 2, 3, 4, like this. So sine is the y value, and y values are positive up here. So the sine is positive above the x-axis, and the sine is negative below the x-axis. So negative sines, positive sines. Cosine is the x value. X values are positive over here, so the cosine will be positive in these quadrants, and the cosine will be negative in these quadrants. Now tangent is y over x, and I'm going to write out each of the signs. So here we have y and x are positive. X is negative, y is positive, x and y are both negative, and x is positive, y is negative. So if I want to know when the tangent is positive, tangent is going to be positive if I have a positive over a positive, or if I have a negative over a negative. So the tangent is positive in the two blue quadrants, the tangent is negative in these quadrants. Some of your questions ask you the question by telling you what sine, the sine, cosine, and tangent are, and these graphs will help you think about what quadrant to put your answer in. Second thing I need you to do is to look at page 370 in your book. There's a ton of vocab. I'm going to spare you a whole video of the vocab. Make sure that you're responsible for all the vocabulary on page 370. You're not going to have to define anything. You're just going to have to know what I'm talking about when I say draw a 60-degree angle in standard position. If I ask you that question, you need to know that you start at 0 degrees, you go here, there's your 60-degree angle in standard position. Second thing we're going to look at, or I guess this is the third, is periodicity, and that's how often the function repeats itself. So for example, if I were going to look at 30 degrees right here, when, and we know that the sine of 30 is 1/2, we want to look at when that repeats itself. The sine being 30 repeats itself as 1/2 right here at 150 degrees, because this sine is also 1/2, and then it doesn't repeat itself again until we get all the way around to 390 degrees. So the sine is 1/2 at 30 and 390, and every 360 degrees after that, and the sine is also 1/2 at 150 and 510, and every 30 degrees after that, every 360 degrees after that, and we have a specific way of writing that, which I'll show you on the next slide. So we just talked about the sine, and we looked at the sine repeats itself in 360 degrees, but we use radians more in pre-calculus than degrees. So since we know that the sine repeats in 360 degrees, we can say that the sine repeats every 2 pi radians. And so that means the values for the sine of t are the same as the values for the sine of t plus 2 pi. And cosine also repeats itself every 360 degrees in the circles. So the cosine of t is equal to the cosine of t plus 2 pi. And the tangent is actually different, because if you thought about my little graph on the first slide about where the tangent was positive here, and the tangent was also positive over here. So the tangent actually repeats itself every 180 degrees. Tangent of t plus pi, because pi is 180. So you're going to look at when the sine and cosine repeat themselves every 360 degrees, and when the tangent repeats itself every 180 degrees. The smallest positive number for which they start to repeat is called the period. Now, we're going to be working with changing periods in section 4.5 and 4.4, but for right now, the periods that you know about are sine and cosine have a period of 360, tangent has a period of 180. The last two examples are fairly simple trig problems, but they might have vocab that you're either unfamiliar with or haven't thought about in a long time. So this first example involves an angle of depression. I'm going to draw a lighthouse right here. I don't draw very well, so there's my lighthouse. And sitting up on some kind of a rock. And this is the water, so therefore my rock is black. And here's my boat. Okay. One thing you learned about in geometry is that an angle of depression is the angle that you look down. So if I'm looking from the lighthouse to the boat, this angle right here is the angle of depression. But notice this angle is not in the triangle that I need. And so you learned in geometry that the angle of depression and the angle of elevation are always alternate interior angles. And so even though they give you the depression angle, you can use it down here as a red angle theta. Her lighthouse is 400 feet high, and we need to know how far away the boat is, x. And so I'm going to follow the steps in the notes I gave to you yesterday, which are label the sides. I did that. Choose an equation. I'm going to choose tangent because the sides that I have are opposite and adjacent. Tangent of 6 degrees. Tangent of 6 degrees is equal to opposite 400 over adjacent x. This is a division problem on my calculator. Since I'm using degrees, you need to make sure your calculator is in degree mode before you type this in. And you're going to type in 400 divided by tangent of 6. When I type that in, I get a pretty big number, 3,805, and so I probably want to convert that to feet, to miles. So 3,805 divided by 5,280 is about 3/4 of a mile. Pretty straightforward trig question. You just might not know what angle of depression meant. So my advice to you in the last chapter was draw a picture, draw a picture, draw a picture. So as long as you do that, you should be good. And we need to talk about one more new vocab word, bearings. Oh, I didn't mean to do that. Oh well. Bearings are the number of degrees clockwise from north. So anytime you're given, okay, just think of it like this. Math people do circles like this, but captains do circles like that. So bearings are from north, mathematicians start at 0. Okay, we have two boats. One of them's a skiff, and one of them's traveling due south for 18 miles. That one's easier. The other one is traveling at a bearing of 38 degrees. What that means is angle from north is 38. So this is 38. Its angle from north is 38. It goes 18. And we just got sort of a problem here because all the sine, cosine, and tangent stuff works on right triangles, and I do not have a right triangle. So I need to deal with that. But if you look at this problem, it's actually an isosceles triangle. And so I can cut an isosceles triangle in half, boom, and get two little right triangles. And so that will allow me to solve this problem. So the bearing of 38 is the angle that's all the way over, so that means I've got two angles right here of 19 degrees. Let's see, how far are they apart? I just need to solve for x and double it. x is the opposite side, 18 is the hypotenuse, so I'm going to go sine of 19 equals x over 18. Type that in as 18 sine 19. That's 5.86. Double it, and they are 11.72 miles apart.